we're asked to simplify r to the 2/3, s to the third, that whole thing squared, times the square root of 20 r to the fourth, s to the fifth. Now, this looks kind of daunting, but I think if we take it step by step, it shouldn't be too bad. So first, we can look at this first expression right here, where we're taking this product to the second power. We know that instead, we can take each of the terms in the product to the second power and then take the product. So this is going to be the same thing as r to the 2/3 squared times s to the third squared. And now let's look at this radical over here. We have the square root, but that's the exact same thing as raising something to the 1/2 power. So this is equal to, so times this part. Let me do this in a different color. This part right here, that is the same thing as 20. And instead of just writing 20, let me write 20 as the product of a perfect square and a non-perfect square. So 20 is the same thing as 4 times 5. That's the 20 part, times r to the fourth times s to the fifth. Now let me write s to the fifth also as a product of a perfect square and a non-perfect square. R to the fourth is obviously a perfect square. Its square root is r squared. But let's write s to the fifth in a similar way. So s to the fifth we can rewrite as s to the fourth times s, right? S to the fourth times s to the first, that is s to the fifth. And of course, all of this has to be raised to the 1/2 power. Now let's simplify this even more. If we're taking something to the 2/3 power and then to the second power, we can just multiply the exponents. So this term right here, we can simplify this as r to the 4/3 power. And just as a bit of review, taking something to the 4/3 power, you can view it as either finding its cube root, taking it to the 1/3 power, and then taking its cube root to the 4th power. Or you can view it as taking it to the 4th power and then finding the cube root of that. Those are both legitimate ways of something being raised to the 4/3 power. So you have r to the 4/3 times s to the 3 times 2 times s to the 6th power. S to the 6th power. And then we could raise each of these terms right here to the 1/2 power. So times, let me color code it a little bit. Times, and we actually wouldn't need the parentheses once we do that, times 4 to the 1/2 times 4 to the 1/2 times 5 to the 1/2. That's that term right there. Times r to the 4th to the 1/2. R to the 4th to the 1/2 power. Times, I might run out of colors, s to the 4th to the 1/2 power. S to the 4th to the 1/2 power. We're raising each of these terms to that 1/2 power. Times s to the 1/2 power. And there's a lot of ways we can go with this. But the one thing that might jump out is that there are some perfect squares here, and we're raising them to the 1/2 power. We're taking their square root. So let's simplify those. So this 4 to the 1/2, that's the same thing as 2. We're taking the principal root of 4. 5 to the 1/2, well, we can't take the square root of that. So let's just write that as the square root of 5. Square root of 5. R to the 4th to the 1/2. 4 times 1/2. There's two ways you could think about it. 4 times 1/2 is 2, so this is r squared. Or you could say the square root of r to the 4th is r squared. So this is r squared. Similarly, the square root of s to the 4th, or s to the 4th to the 1/2, is also s squared. And then this s to the 1/2, let's just write that as the square root of s. Square root of s. Just like that. And let's see what else we can do here. So we have, let me write these other terms. We have an r to the 4/3 times s to the 6th times 2 times square root of 5 times r squared times s squared times the square root of s. Now, a couple of things we can do here. We could combine these s terms. Let's do that. Actually, let's write the 2 out front first. So let's write the 2 out front first. So you have 2 times, now let's look at these two s terms over here. We have s to the 6th times s squared. And when someone says to simplify it, there's multiple interpretations for it. But we'll just say s to the 6th times s squared, that's s to the 8th, right? 6 plus 2 times s to the 8th power times, now this one's interesting, and we might want to break it up depending on what we consider to be truly simplified. We have r to the 4/3 times r squared. R to the 4/3 times r squared. R to the 4/3 is the same thing as r to the 1 and 1/3. That's what 4/3 is. So 1 and 1/3 plus 2 is 3 and 1/3. So we could write this times r to the 3 and 1/3. And that's a little inconsistent. Over here, I'm adding a fraction over here. With the s, I kind of left out the s to the 1/2 from the s's here. But we could play around with it, and all of those would be valid expressions. So we've already dealt with the 2. We've already dealt with these two s's. We've already dealt with these r's. And then you have the square root of 5 times the square root of s. And we could merge them if we want, but I won't do it just yet. Times the square root of 5 times the square root of s. Now, there's two ways we could do it. We might not like having a fractional exponent here, and then we could break it out. Or we might want to take this guy and merge it with the 8th power, because you know that this is the same thing as s to the 1/2. So let's do it both ways. So if we wanted to merge all of the exponents, we could write this as 2 times s to the 8th times s to the 1/2. So s to the 8th and s to the 1/2. That would be 2 times s to the 8. I could even write it as a decimal, 8.5, right? 8 plus this, you could imagine this is s to the 0.5 power. So that's 8.5 times r to the 3 and 1/3. I'm kind of mixing notations here. I have just a decimal notation, then I have a fraction notation, mixed number notation, times the square root of 5. Times the square root of 5. This is one simplification. I kind of have it in the fewest terms possible. The other simplification, if you don't want to have these fractional exponents out here, you could write it as, I'll do this in a different color. You could write this, and these are all equivalent statements. So it's up to debate what simplified really means. So you could write this as 2 times s to the 8th. S to the 8th. Instead of writing r to the 3 and 1/3, we could write r to the 3rd times the cube root of r, which is the same thing as r to the 1/3. We could write r to the 3rd times r to the 1/3. R to the 1/3 is the same thing as the cube root of r. And then you have the square root of these two guys. Both of these guys are being raised to the 1/2 power. So you could then say times the square root of 5s. I like this one a little bit more, the one on the left. To me, this is really simplified. We've merged all of the bases. We have these two numbers here. We've merged all the s terms, all the r terms. This is a little bit more complicated. You have a cube root. You have separated the s's and the r's. So I would go with this one if someone really wanted me, said, hey, Sal, simplify it how you like.